Welcome guys, let us solve this interesting number logic challenge. So let us say x to the power of y minus y to the power of x equals 17. So guys, before we continue, let us try to state the domains of x and y. So first of all, x and y are integers. And also, due to the nature of the equation, we can see that x and y cannot equal 0. So if we have x to be 0, for example, we have 0 to the power of y, then minus y to the power of 0, and that is going to give us 0 minus 1, which does not equal 17. Therefore, x cannot be equal to 0. Also, y can't be equal to 0 for the same reason, because we have x to the power of 0 minus 0 to the power of x. Same thing is going to give us 1, which cannot equal 17. And also, both of them cannot be 0, because then we have 0 to the power of 0, which is going to be invalid and undefined. So, x and y cannot equal 0. And also, x and y cannot be less than 0. It's not allowed. Why? Because if it's negative, for example, it's going to give us a very tiny fraction, and we can't subtract a whole number from a tiny fraction to get 17, right? Also, when negative, it's going to give us a fraction, and also the difference can be 17. And also, if two of them are negative, it's going to give us a small fraction minus another small fraction, and that can equal 17, right? Therefore, we can establish our domain and say x and y must be a positive integer. Now let's solve the question putting this domain in mind. We can rewrite this our expression as x to the power of y over 2 all squared, then minus y to the power of x over 2 all squared, and that equals 17. So notice there that we have a difference of 2 squares. Therefore, we can go ahead to factorize the expression using the difference of 2 squares. So we have y over 2, then plus y raised to the power x, and this equals 17. So now moving further, let us try to write out the factor pairs of 17. So we know that the factor pairs of 17, we have 17 and 1. Also, we have minus 17 and minus 1. So these are the two factor pairs of 17. And don't forget, due to our domain restriction, minus 17 and minus 1 is not allowed because x and y must be greater than 0. Therefore, we are going to be making use of this factor pair. And then we will write our equation, and then we'll say all this equals 1 times 17. When we study this equation, you see that this is subtracted and this is added. So therefore, we can go ahead and equate the factors. X to the power of y over 2 minus y to the power of x over 2 will be equals to 1. And also, x to the power of y over 2 plus y to the power of x over 2 equals 17. So the added term must be greater than the subtracted term. So we can go ahead to solve the simultaneous equations and say this equation 1 and this equation 2. So when we add the equations together, you see that 2x to the power of y over 2 would be equals 1 plus 17, that's 18. And then we have x to the power of y over 2 to be equals to 9. And therefore, squaring both sides, we have x to the power of y equals 81. So let's call this equation 3. So let us leave this here. When we subtract these two equations, we have minus 2y to the power of x over 2 to be equals minus 16. We have y to the power of x over 2 to be equals to 8. And then when we square both sides, we will have y to the power of x to be equals to 64. And also we can call that equation 4. So let us write this here. And now, because we know that x and y are both positive integers, and also 64 and 81 are not big numbers, so we can test for small values of x and y. And also, because this is an even number, therefore the base must be even, and that is obviously 4 to the power of 3, because 4 to the power of 3 gives us 64. So that's y is 4, x is 3. So let's try that in our second equation. So let's say 3 to the power of 4, and that gives us 81. Then finally, therefore, x equals 3 and y equals 4. This satisfies our domain, therefore the correct answer.